Quantum and life, the incredible microscopic objects and the complexity of life. Is there any connection between the two? Quantum is the theory that describes microscopic particles, the building blocks of the universe, like molecules, atoms, and electrons. You probably don't know much about the consequences of this theory, but we live now in a quantum revolution. Quantum is disruptive. Quantum computing will disrupt our society in an unprecedented manner. It brings immense computational power, making the impossible possible. Quantum is counterintuitive. Quantum particles behave in a way that is so different compared to anything that we experience in our daily life. They can be in several places at the same time. They can lose their individual identity. They defy our imagination, and yet they are real. Quantum is fundamental. It has been proven by innumerable experiments. Quantum is the most fundamental theory ever discovered. And yet, if we try to study and simulate complex molecules and objects with conventional computers, we encounter a problem because we would need a memory larger than the number of atoms in the universe. And this is causing major disruption in several disciplines. Drug development and discovery is one of these examples. We know that over the years there has been a tenfold increase in the spend for research and development, but the number of drugs brought to market remains approximately the same. This is due to an oversimplification in the cell biology. We are failing to model precisely and with sufficient accuracy the binding of small drugs, molecules, and proteins in our body that are causing diseases. And as a consequence of this, 90% of the drugs that we give to our patients do not treat 50% of the population. We obviously must do better. But there is hope because quantum computers possess exactly the same properties that make molecules difficult to simulate. In Algorithmiq, we are developing software for quantum computers. Our algorithms allow to explore the gigantic space of molecular compounds that is estimated to contain 10 to the 63 molecules. This is a number similar to the number of atoms in 10 million solar systems. We are able to provide quantum-based models of how drugs bind to proteins in our body, but the problem is that existing quantum computers are very noisy, so we need to find ways to clean them from noise and errors and restore the quantum properties. This woman is Margaret Hamilton. With her team, she programmed the computer that brought men to moon and back. That computer had 100,000 times less processing power than a modern iPhone. And still, she developed this huge code that you see in the picture to correct and prevent from errors. Recently, she said, looking back, we were the luckiest people in the world. There was no choice but to be pioneers, no time to be beginners. Today, we are the pioneers. We are providing better health for everyone, bringing quantum to life. Thank you.